Hey everyone, Geophysicist Stefan Burns here. We are right now in a historic solar storm impact. Really, this can't be stated enough. This is a historic solar storm that's coming in right now. We had an S4 radiation storm, the strongest in 20 years. Solar wind velocity right now is over 1,000 kilometers per second for the bulk of the solar storm. It's been about 6 hours now of impact. That's crazy. The solar wind magnetic field right now is over 60. The shock impact was over 90 nanotesla. I mean, it's been insane. The only reason this solar storm hasn't been stronger is the fact that the magnetic field configuration hasn't necessarily been conducive for creating a strong geomagnetic storm. So it's very similar to 1972, in fact. The solar storm that hit 1972, I call that the lucky storm because its magnetic field configuration wasn't such to create a huge disturbance. It did set off sea mines off the coast of Vietnam. They just deployed them a few months earlier. That came in incredibly fast. But this solar storm transited from the sun to the earth in about 30 hours, and anything under 30 hours is very fast. That's just what happened. We're in it right now. We're starting off by looking at our magnetosphere, these visualizations that depict the magnetosphere, the density, the pressure, the velocity. Here we're specifically looking at the velocity because this solar storm is that fast. That's the key. In fact, that's all red here. It's actually 600. It's well above 600 kilometers per second. It's 1,000 kilometers per second. But this is showing nicely the compression of Earth's magnetosphere as a result of this solar storm. So these animations are visual aids. They're not necessarily the best in terms of like being able to look at this, extract data from that, and then run with that, for example. But as a visual aid, it really shows how this magnetic field has been crunched by the sun. Here's where it was right before. So this is showing right here that first impact. Boom, there it comes in. This is wild. So hello and welcome everyone. I'm your host Stefan Burns, geologist, geophysicist, space weather guy, your cosmic bro, helping you understand what is happening here on Earth. I'll say it once. I mean, I hope I don't say it again. As the live stream goes on, we'll see if I remember, but I will say that we forecasted this solar storm hitting Earth more than a year in advance. You can go back through my video record. We've been talking about the historic planetary geometry that's active right now for more than a year. And of course, as we got closer and closer to that, we've been talking about it more and more. And well, right as this has been happening, we have this solar storm impact. And again, it's historic in many aspects. S4 severe radiation storm, the strongest since the Halloween storms of 2003, which are arguably some of the most historic solar storms that Earth has hit during the modern space age that we've been tracking this stuff. Of course, we have the Carrington event. This is not a Carrington level impact. This took about 30 hours to reach Earth. Carrington, the Carrington storm was powerful in the fact that it reached Earth in about 16 hours, maybe 18 or so, less than 20 though, not less than 14. So in that zone, about 16 hours or so, it hit Earth. It also had an incredibly strong magnetic field, and it was situated such that it connected to Earth's magnetic field. Right now, we don't have that connection. There are other ways it connects. We have a northward field. We'll talk about that. It's actually very interesting, especially as it relates to high magnitude earthquake activity, which is what we've been talking about on the channel. This is not the only forecast I've been putting out. We've been talking about how planetary geometry lines up with solar storms for a while. Looking in advance at the geometry for January of 2026, we forecasted that there was a much higher likelihood of very powerful solar storms. That's what we've seen. We could have more. That sunspot now is facing Earth center. It could blast off again. Actually, I think that may occur. It's looking active. We'll talk about it. We'll look at it. But also, these alignments are well connected to high magnitude earthquake activity. And when you have a northward field like we have now, it charges up the global electric circuit in unique ways that a southward field doesn't. So it penetrates a little deeper into the Earth, it seems. It creates stronger telluric currents. It's very interesting. So, yes, we are going to go through a lot. This is going to be probably a longer live stream. So we'll circle around a few times, I'm sure. And I'll look at the chat. And if there's questions that are good questions that pop up during, I'll answer them right then and there. So this is going to be a bit more interactive than normal because this is all happening right now. So it's not just a, hey, I got this data point, that I want to show you. There's your presentation. We're doing this together. And if the field flips southward at any moment, I'm going to cut it and I'm going to run outside, because the moment that happens, if it does occur, and I think it probably will at some point, it's going to be a spectacular aurora viewing event, because right now the solar wind is still maintaining incredible strength. It's really insane what's happening right now. So here's our real-time solar wind for the past day. And we see that we had our very low KP index here, a measure of geomagnetic volatility just before it came in. That's typical. Often before these really big storms, the geomagnetic field gets very quiet, and then you get that shock impact. That is what occurred. Immediately going up to an 8.33 on the KP index. It caps out at 9. Okay, so it doesn't go beyond 9 for the KP index. We have another way of measuring this, a higher resolution called the HP index, HP 30, HP 60. We'll look at it. That goes beyond 9. We actually had 1 hour where we were at a value of 10. So this is big, okay? But for the KP index, 8.33 here. And then we see 8.67 for the past 3 hours. Current conditions now are G2, but we're probably going to get another value around 7 to 8 for the next 3 hours or so. And here's our interplanetary magnetic field. So we went from values of, let's say, 5, right around 5 or so. The black number there is the total field strength. The red line is what's called the, it's the vertical component, the BZ component of the magnetic field. Because we can measure the magnetic field in an infinite amount of vector directions. But we choose to do north, south, east, west, the whole deal, like X, Y, Z, okay? So they look at that, or we look at this very closely, because when it goes negative, like we see here, anytime we see this like light purple shaded region, that's the southward component going negative. That means that we have a really strong connection to the solar wind, and therefore we're having really powerful geomagnetic activity. So we see that we had that at the beginning of this initial impact, and we were at very high values in here, like 56, negative 49. That is insane. We almost never see values like that for the solar wind or for the solar storms, okay? Normal like enhancement for like a strong one will be up to 30 nanotesla. The moment you're pushing beyond 50, it's a big impact. So this could turn into one of the biggest storms of 2020, of this solar cycle, if it flips negative. Because here we see then it charged all the way up to 90 nanotesla. Average is 5. So this is an 18 times increase over normal. And one of the key things to understand here is that the magnetic field drops off via inverse square law. So as you double the distance, it drops off quite dramatically. So you double it, it drops off by 4. Triple, it drops off by 9, okay? So as you move out, it really decreases. So when you have the magnetic field go up to 90, it's not able to push a little bit closer into Earth. It's able to push a lot closer into Earth. In fact, this was so strong that it crunched the magnetic field in closer to the Earth than geosynchronous orbit, which is 5.6 Earth radii. So where we have a whole bunch of geosynchronous satellites flying around, providing critical infrastructure and more, they were all of a sudden exposed directly to this solar storm impact, no longer having any sort of magnetic field protection, because that solar storm pushed the magnetic field in deeper than that. It still may be there or right around that zone. That's crazy. Magnetopods are normally at about 10 Earth radii, so, or on the sunlit side. You see that we're still at incredibly high values of 56. The The vertical component, though, is at a field value about 39 or 40 positive, meaning we don't have that strong negative connection, meaning that we don't have the absolute prime conditions for a geomagnetic storm that goes to straight KP index of 9, G5 levels, and there's aurora, let's say, in Jamaica, right? Yeah, man, we're not having that. We could have it, though. As we see here, this can flip really quickly. We did. If that had held, let's say that had held, it would have been happening, all right? It would have been the Rasta event of the decade, of the century. But that did not occur. It then flipped northward. And that's interesting because it charges the Earth in unique ways compared to a southward component. The southward component and that sort of geomagnetic storm, almost like it dissipates energy more. As aurora and such. When it's northward, it forms these strong Birkeland currents and it charges up the interior of the Earth more. It's very interesting. Limited data and research on that, but it's really quite wild. Also, just FYI, I'm seeing that I'm having issues with an up-to-date chat for this live stream on StreamYard for whatever reason. I don't know why, but it is coming in bursts and then it's completely pausing. So it may be difficult actually for me to address you guys in the chat this way. There may be an alternative way I can get this figured out, but as of this moment in time, I'm streaming this to StreamYard. So we'll see. Hopefully that gets resolved, but this happened also a couple streams ago. Don't know why. So the other key thing to look at here is our solar wind. What the heck? Look at this, 1,100 kilometers per second, 1,000 kilometers per second. This is insane. A strong solar storm impact gets us to 700, 800 kilometers per second, right? But it'll quickly drop off. That's like the shock of it, okay? This is 1,000 kilometers per second and it's holding. I mean, yeah, at one point it was like nearly 1,200, but we see that it's effectively holding 1,000 kilometers per second. That's the bulk velocity of the plasma. Again, it transits Earth in about 30 hours, a little bit less than that. So, wow, this is a historic solar storm impact, and in a variety of ways. We can look at, I think, no, well, yeah, we can look here, and then we'll look at another graphic provided by NOAA. This is our space weather overview. So it shows a very clear progression. Let me make this smaller so you can see it all in one go, okay? Because this is a beautiful example of how space weather works. We have our solar X-ray flux, a measure of these solar flares, and you get a big explosion, X-ray flux goes up, big boom shakalaka. This was a long duration event. Look, we hit R3 levels. That's an X-class flare hitting R3 levels. Long duration in R2 and R1, and then we've cooled off. We had some activity since. I think we're likely to have another one, but we'll see. We'll see. Immediately afterwards, we see that solar proton flux started to go up. It charged up beyond S3 into S4 level territory. We haven't seen those levels since the historic Halloween storms of 2003. Crazy stuff. So this is the first time in 20 years we've had an S4 radiation storm. We have about 10 S3 storms every solar cycle or so, approximately. First time we've had an S4 since solar cycle 23. Okay. And again, forecasted a year in advance using planetary geometry. Okay, here's our geomagnetic activity. Immediately 8 plus, 9 minus. That's a G5 minus, that's a G4 plus level right there. And as we'll look at with the HP indices, we actually went up to values of 10, and we could get back to values like that if that field flips to the south. And that could happen at any moment because these solar wind structures can be very dynamic. So one thing to point out here is you have this solar storm coming in, and let me pull up a video for you of a solar storm coming in so I can really kind of illustrate this for you nicely. This should be nice right here that I'm going to show you. So let's check this out. And I think there's some weird audio on this. Let me turn that off. Okay. Yeah. I guess I was playing some audio. Sorry about that. So let's look at this. Here we have a solar storm, a coronal mass ejection launching from the sun, and then I also layered in the Earth here. I think originally this animation was for like Mercury or something. It's like, no, make it for the Earth, baby. Okay, this spreads out, it gets bigger, it gets wider. What happens with these really, really, really big solar storms is that, of course, there's a whole bunch of plasma in between, the solar wind. It's moving faster. We know this thing was moving incredibly fast. It's sweeping up all this plasma in the solar wind. This is becoming denser and denser. So certain dynamics won't occur unless it's a really fast solar storm. The other thing to keep in mind with this one is that there was a coronal hole high-speed stream that was sweeping and bound to impact the Earth right as this launched from behind it. And as a result, the two combined, it was able to move faster because the overall interplanetary medium was lower density, so it encountered less resistance. It then caught up to that region of plasma at the front of the high-speed stream called the co-rotating interaction region, which is higher density, already kind of sweeping and piling things up. And then it just like, boom, like right like that, and it shocked onto it. And that's why we had such an incredible impact. So it's a convergence of factors. When you have enough velocity on these things, it's now sweeping up everything so fast that effectively all the plasma in between the sun and the Earth forms a shock wave, a giant electromagnetic pulse. That is what hit us. As this thing travels through space and it's encountering these particles, some of them get picked up and move through these electrostatic double layers in this coronal mass ejection. It's not just magnetic fields. All the space people are always magnetic field this, magnetic field that. It's electromagnetism. Maxwell, right from the beginning, you know, it's not that difficult. It's not just magnetic fields. Magnetic fields are cool. Electric fields are cool too. So it's also electric field dynamics. You have these very powerful electric currents. You have these electrostatic double layers within the actual body of plasma. And this is effectively where you have a big difference in the electric voltage. So there's a gradient, a very powerful electric gradient that can accelerate these particles really quickly. So as it's moving along, it's sweeping up these particles and then shooting some of them out like super high velocity near the speed of light. They then begin peppering the Earth. That's what's happened. That's why we had an S4 radiation storm, because this was moving so fast, combined with that coronal hole high-speed stream structure, it just became a very unique dynamic situation that we almost never see. It's a near-Carrington level impact. That's why we had the S4 storm, and now we're in that G4 storm. Though right now it's saying G2 levels, but we'll look at the latest data. So let's actually look at our HB30 index so we can get this high resolution look at our geomagnetic volatility. We're going to look at the magnetic field readings too in some of these locations in the Arctic. I'm sure they're going nuts right now. Europe had a show because they were the ones that actually get the impact because it came in faster than expected. So here's our HB30 index. We see it ramp up, and the values start at 1800. It's every 3 hours. So actually that first KP index includes right there 1 hour of these low field values of 4. So it would have been higher if it was exactly starting right here, for example. And that value right there is 8. So here we have 8, there we have 9. Within 30 minutes after this impact, we're at a KP value of 9, or well, an HB30 index value of 9. That's a G5 storm. Within 30 minutes, we're at G5 levels. If we look at this high resolution look, that's that EMP shockwave effect. Okay, then goes up beyond 9, goes to 10 for an hour, 30 minutes, 30 minutes. Now we're cooling off. We're at about 6 for the last one. But again, the moment that flips southerly, we're rocking and rolling. And yeah, my chat is freaking out for some reason. So I hope you guys are having fun there. But unfortunately, I am effectively disconnected from the chat because it's not coming in. We you know, everyone pray for a moment to help this this work out. But yeah, we're having some issues there. So this is going to be going on for at least another 24 hours. This is probably going to be like a 2-day long event. You know, this shock impact may be the strongest part of the impact overall. But if that field flips to the south, then that could change. If you go back to that really quick, you know, this is our 1-day view right here. We often see these solar wind structures last for 12, 16, 20 hours. It's quite dynamic. The fact that it's still over, now it's just at 1,000 kilometers per second, it's still at 55. If we get an 8-hour long duration where it's like 45 nanotesla, let's say, as it started to cool off, but it flips down to -30, we're cooking, man. You're gonna be able to put an egg on the sidewalk and see that thing sizzle. It's gonna be wild. So if you have the energy, stay up tonight. If you're in the United States, if you're in Canada, if you're in Alaska, maybe if you're in Jamaica, all right, stay up tonight because this could flip at any moment. So this is linked in the video description, the real-time solar wind. This is being observed at the L1 Lagrange point, so about 1% of the distance from the sun to the earth. And at this velocity, it's about a 20-30 minute heads up. So what we're seeing here is maximum 30 minutes in advance of what's going to happen on Earth. So if you see this all of a sudden flip to the south, then that's, you know, you have about 30 minutes before you may start seeing a burst of aurora. There's another thing that you can check too. If you go to our products and data, we'll go to our magnetometer. And this is a key measure. This is measuring the magnetic field. This is insane. I'm glad I pulled this up. I often don't check this page, but this is, I'm glad I did because this is wild. This is looking at our magnetic field values at 5.6 Earth radii. As you remember, we had that magnetic field crunch in closer than 5.6 Earth radii, which is geosynchronous orbit, which is not common. It's very uncommon to see that. That's what's happened just in the past few hours. Our magnetic field values here typically range in that 0 to 100 nanotesla range. Look at how they spiked up nearly to 400. Massive swing, 500 nanotesla swing approximately right there. The thing to keep in mind if you're using this for forecasting is that it's when you have it really plummet down and then snap upwards, that's when you get a substorm. So I could go more in depth on that, but in general, to keep it simple, that's basically what you look for. So if this starts to snap upwards, that's when you know it's a really good time to go outside. Like right before this live stream, I went outside because I'm in a place where I could, you know, maybe see some aurora. Definitely see some if it goes southward right now. And I didn't really see anything, long exposure, nothing popped up. Even though we have the super high velocity, the solar wind strong, we just don't have that southward component. It's really important. So, but if I see that flip or it goes south, right, I'm out of here, folks. I love you all, but I'm out. I want to see the aurora. I want to do it. All right, I want to see it for myself. I'll be seeing it in Sweden soon. I'm going to Sweden for February. So that'll be great, and expecting to see lots of, I'll be up in the Arctic Circle. So that'd be really cool. Hoping to live stream a geomagnetic storm in the aurora for you from Sweden. So we hope that we get some awesome displays of Earth energies while there. Let's look at our magnetic field here, okay? This is going to be for the past 3 hours, and this is pretty wild. Does look like the chat is working now. I am not Swedish, though. I don't know, maybe it's a little bit in there. I'm more Polish. Whoa, what was that? That must have been that shock impact. It's starting to level off now, as you can see, but just incredibly volatile about 3 hours ago. I wish this was like a 9 or 12 hour model run that they did. It is possible to download this data. It takes forever to turn into a visual, but look right here at the beginning. Whoa, this is crazy. It's crazy. That's what I'm talking about. This is historic. I think a lot of people are just in general, and this isn't a critique, I think it's understandable, are a little slow to understand the scale of things that happen as it occurs. I think that's actually very common. It's a more common thing. When really epic things occur, it takes time to really understand that and integrate it. And in the moment, you're just experiencing it. You may not fully recognize what's happening in the moment. That's effectively occurring right now. So when that solar storm launched off from the sun, a lot of people are like, oh, maybe a glancing impact because most of the bulk is going east. If you're saying it's a G3 storm, you're insane. Like someone literally called me insane for saying G3 minimum with the first forecast when we saw the flare. I mean, come on. It's right. You need to develop a sense of this stuff. And there's just in general like a human thing with like wanting to downplay stuff. But we live in historic times, and this is one example of that. Solar cycle 25 was stronger than expected, quite a bit so early on. Now it's closer to the prediction models, but they also nudge those upwards to fit the data that was coming in. This has been a historic, not historic solar cycle, but it's been a much stronger solar cycle than expected. There was even some forecasts. If you look at some of the NASA stuff from a few years ago, they were expecting perhaps a grand solar minimum. There's some visuals that they made showing solar cycle 23 and then 24 and then 25 like flattening out like a grand solar minimum. That didn't occur. So we're in it. We're in it, baby. Here we have our real-time coronagraph imagery for the past 24 hours. And yeah, we'll get this guy punched in there. Let me turn off that. I see you all in the chat. It's working now, thankfully. Thank you for all the super thanks. Before we move on a little bit further, we have a super thanks here from Sonora. Sonora, thank you so much. From Roxy at the beginning before we went live. Awesome. One from JP here. And Sonia, thank you so much. So, and then this last one here from Chocolate Espresso. Thank you all for the super thanks. It's much appreciated. Much love to all of you. So here we have our coronagraph view. This is our C3, our wide angle. There's a lot happening here. You'll notice this solar explosion go off right there. So there's full halo, but we really see that if we had been a little bit further behind in our orbit, this would have been probably a Carrington level impact because there was more plasma that went off to the side. So it was slightly behind Earth's orbit. It's probably passing Earth's orbit behind us right now, okay? All those particles that you see, that snow, as we call it, that's all those high energy particles hitting the sensor. And they actually cause it to white out. That is what happens with an S4 radiation storm. So again, we can look at this, and that is insane. That is really, right? What? And okay, so that's crazy. That's a wallpaper for your phone if you know this stuff. That's wild. Now, one thing we were also talking about well in advance of this happening was 2006. There was a sequence of Cazimis that occurred. This is certain conjunctions with the sun. We call them Cazimis in certain circles. And it was very similar to what occurred just right now and is happening right now. And we saw two big solar storms form as a result of those planetary geometries that then launched out towards Earth. So there's big sunspot growth at the very end of a solar cycle, and then big solar storms launch off. It's been almost identical to 2006, what's been happening now. They had two of them back to back. I wouldn't be surprised if we get more. So here are those planets, okay? We have Mars, we have Mercury, we have Venus. Mercury's about to do superior conjunction. We often see heightened solar activity during Mercury superior conjunctions. It's seen as the activator. If you research into planetary geometry, that is something that comes up time and time again across a variety of researchers and their efforts in studying into this. And well, we just saw it in folks. We just saw it in play. So Mercury there swinging in seems to have activated this whole configuration, but Venus is moving ahead. Mars is now moving behind. It'll become more of a morning star, you could say. Venus becoming an evening star. Mercury soon to become an evening star. Jupiter directly behind us. Jupiter's directly behind us. Interstellar objects behind us. Pluto's in front of us. So this planetary geometry was very, very significant. And we were looking at that about a year ago, at least. And thinking, okay, we haven't seen something like this in a long time. Here it is right here. This is the planetary geometry for today, right now. We see Mars, Venus, Mercury, Earth, Jupiter there. You see that they're almost in a perfect line. A few days ago, they were closer to a line right here. This is back around the 10th of January or so. And we see that a little bit of time has passed. The geometry broke a little bit, but not that much. And in general, planetary geometry is a bit of a time window. So it's not exactly going to be the day of. Sometimes it is. Sometimes it's kind of wild like that, but it's more like a 2 weeks on either side. That seems to be kind of the more critical zone. And well, we were definitely in that. Okay, so this is the planetary geometry for now. We also see, if we go like this, that Pluto is on that side. If you go here again to the 19th, we see that Pluto is participating in that alignment. Pluto is this like modifier. If you study this stuff, it makes things more powerful, bigger. That's why I'm not surprised that this came in strong. And we talked about that in the recent videos. Okay. Now, if we go back in time to the Carrington event, check this out. This is pretty cool. So we'll drag our good friend Neptune here, and we'll go back to the Carrington event, 1859. Neptune was roughly in the same position of the sky also back in 1859, which is pretty cool. See that? I go forward. Look at that. See, you know, there's a magic to the universe. It's pretty cool stuff. So we're gonna have to grab Earth again. Sometimes this app can glitch out a little bit, but we'll go back to 2026 right here. There's Neptune right here. Okay. And let us go to 1859 again. Oh, what are the chances? It's right there. Wow. Okay. So we'll drag forward even a little bit further to get to 1859. And September specifically, here we go. Look at this. Oh, it's the same synodic cycle for Mars and Venus, because they have every 6.6 years, every 2,338 days, they both are on the other side of the sun while Earth is over here. So that is a Mars-Venus solar conjunction cycle. It lasts about, it's every 6.6 years that occurs. For the Carrington event, just before it occurred, we had Saturn, Mars, Venus, Sun, Mercury, and Earth in a very similar arrangement. This time Saturn was with Mars and Venus, whereas this time, that time Saturn was with Mars and Venus. This time Jupiter has been with Earth. But it appears that when you have an outer gas giant participate in this synodic cycle, big things can happen. Big events can happen. And well, we saw that in 1859 with the Carrington event. That's the planetary geometry. Not identical, though this configuration is nearly identical with Mars, Venus, and Mercury, though what we had this time was a tighter configuration. Sometimes that synodic cycle is a bit looser. But yeah, this is pretty significant. We can also go to 2006, and you will see a very similar configuration to what's occurring right now, because that was also one of those Venus-Mars synodic cycles. And that was around October. So here's 2006. And if we go forward like that, there we have it. You'll see that Jupiter is close, but not exactly there. And you have to go into November here to get that Jupiter superior conjunction. So it was a longer time period here where then you had a Jupiter superior conjunction. But back in 2006, we had our sunspot number in October at about like 15 or something. And then it rocketed up to 60. Let me show you that data. This is pretty cool. So let me load it in here. We'll get our 2006 Kazemi sequence loaded up. I've shown this before. It's almost identical to what's been happening right now, which has been really cool to see, because we've been using this as a forecasting parallel effectively. And well, we saw it happen. So here it is. This is the planetary Kazemi sequence. 2006, we see this Mars-Venus conjunction occurring with the sun. Look at our sunspot growth, going from 13.2 monthly average in October to 60 in December, a 4x increase, actually more than that. Notice the activity start to build up after that conjunction, just like what happened this time. We'll then see Mercury coming in here, inferior conjunction. We're having the superior one right now. All of a sudden, Jupiter starts to do a superior conjunction. We start to see more activity from these sunspot groups as they rotate towards the limb, right there. 7 days later or so, right, we get a solar storm launch out towards us right here. That's the first one. There's that snow. Here's the second one following up right behind it. Boom, shakalaka. Almost identical, except this time we haven't had 2 solar storms. We've only had 1, but we still have some time left. These sunspots are Earth facing at this moment in time, and so we could certainly have that occur. And I think that's actually quite likely. I think these sunspots are not done. We can look at them with our SUVI imagery and see what they're up to at this moment in time. So let us do that. Okay. There's just a brief pause there. I switched to a faster internet connection. I didn't realize I was on the slower internet connection. So I think everything's been fine though. Hopefully this helps the chat out as well. Looks like it has. So we'll get this. I think this one will work for us. Yeah, that should do it. Yeah. So here's our sun for the earthquake in SoCal. Ooh. Just had an earthquake in San Diego. Well, I'm not there right now. Okay, sun, you're going to have to wait. And I'm not talking about my son. I don't have a son. Let's see what this is all about. Earthquake in San Diego. Yeah. Oh, 5.1. All right. Wow. Just happened, folks. We're doing it live right now. In between, okay, not San Diego, but close to it. In between Los Angeles and San Diego, but more to the east, right on the San Andreas. Wow. Okay. Depth, 9 kilometers. And let's turn off our, well, yeah, let's turn off our UTC time. So that occurred at 20:50 or 7:56 p.m. So about an hour ago, if that's right. I think it's about an hour ago. Or no, it just occurred right now, like literally right now, three minutes ago. Oh wow! Now it's down to a 4.6. Did you guys feel that? Did some of you feel that? Is that why you're reporting on it? Like you literally felt the earthquake? Let me know in the chat if you felt that. Wow. Yeah, but someone also mentioned we had a magnitude 7 off the coast of Oregon recently. We can check that out here. Here's our magnitude, or not magnitude 7, I'm sorry, magnitude 6. We did have a magnitude 7 here at the Triple Junction back December 2024. Probably thinking about that. Magnitude 6 here just off the coast of Oregon along the Juan de Fuca. In general, California is overdue. This is a big earthquake, though. This is just another sign that there's bigger earthquake activity coming to California because it is increasing. Over the past 3 months, we've been seeing this increase of activity. These quakes in Susanville were quite odd. We have a magnitude 4.9 there, magnitude 4.7. Those are quite unusual. So yeah, California is looking due, specifically the Bay Area. I'm really thinking the Bay Area, unfortunately, that just looks like it's just looking like it's ready to go, but we hope I'm wrong. You know, generally I hope I'm wrong with this stuff. I'm in a tough pickle with this forecasting and everything, because often I'm like, I hope I'm not right. But it's not often that's the case. I seem to be right more often than not, which is great for our ability to understand this stuff and to move forward with, you know, better forecasting methods and everything. But yeah, there's real world implications for this. Power grids perhaps can go down with the big storm, you know, earthquake rumbles under your feet, the house can collapse. You know, this is not good stuff. Let's go back to the 18th. Let's set this for 2 days. And let's go to Uppsala because they have a good magnetic field observatory, Uppsala, Sweden, and they get crazy swings in their magnetic field. Let's check it out. This is our intermagnet data. Let's actually set it up for just 1 day here then. Oh, that works. Lets me stand off to the side here. And I think I'm going to rearrange. All right, so here is our magnetic field data. And actually, maybe I should set this. Yeah, there we go. Here's our magnetic field data out of Uppsala, Sweden. And we see our 3 different components and also our total magnetic field here. And we're looking at some pretty big swings, though not as big as I expected. Again, we have that northward field configuration. That's key. We'll talk about that more in the video, okay? So we see that overall about a 1,000 nanotesla swing in the field out of Uppsala, Sweden at this moment in time. And that is mostly concentrated in the z-axis. So some fluctuations in the horizontal as well. Pretty significant. That's actually about 1,000 nanotesla as well. Vertical 1,000 nanotesla, but the y component horizontal, not that much of a swing at only about 600. It's actually still quite a lot. Just in general, the magnetic field experiences just a massive surge of volatility with these sort of solar storm impacts. That's what we're seeing right here. So that's Uppsala, Sweden. And if we go to, I think there's some for Greenland, perhaps. Let me see if we can find that. I don't remember what it's called. Here we go. And here we have our magnetic field swings for Greenland. And we see that's even more significant. So here it says 51,400 nanotesla going up to 53,400 nanotesla. That's a 2,000 nanotesla swing in the magnetic field out of Greenland for the storm thus far. So that is quite significant. That's just a Z component. If we look at our X component, we're seeing similar amounts, 13,500 top, 11,500 here. So it's actually greater than 2,000 nanotesla for the X component. This is Greenland. The magnetic field is in the northern, the pole at least in the northern hemisphere is closest to Russia at this moment in time. Maybe we'll find something for Svalbard in here. I think they do. And there is maybe an easier way I can get that data. So let's go here and look at our map. Let's see what they show for 3 more aftershocks in California. Okay, we'll check it out. Earthquake swarming near Indio, California. Yeah, this is happening right now, so we'll check it out. Map of observatories. We got a lot happening right now. We got the historic solar storm, planetary geometry. 3i Atlas is about to, line up with Earth in relation to its anti-tail, its sunward-facing jet. That's about to hit that alignment with Earth. We had the new moon yesterday. We have the Superior conjunction Mercury in just a couple days. Pretty wild stuff. Here's Svalbard. Hornsund, HRN, Hornsund. So let's go back now. And we can look at Hornsund. That'd be an interesting name to have. Probably get bullied on in school with that name. Maybe it'd work out for you though. With the horn in there. Hornsund, where would you be? There we are, Svalbard. You can go to Svalbard. You don't need a visa. This is what I've at least heard, that so long as you show up, they're happy to have you because it's so desolate, remote, and just difficult there that they're like, we'll take anybody. So you can just show up and you're in, baby. But you're in Svalbard. You may get eaten by a polar bear. So watch out for that. Our swings in Svalbard, quite large too. 53,600 nanotesla down here. This is total field. Up top, 55,400. So we're looking at, again, almost 2,000 nanotesla pulses. So this is a big storm. This is a really big storm. The only reason we're not seeing this be a lot bigger is because of that northward field configuration, which has not changed at this moment in time. We need to turn this off. I need to reduce the load on my computer. Let's go back to our sun here. Look at that, it just finished loading. We would have been stuck there the whole time. How about that? How about that? Here we go. And this is showing the past 24 hours. So this is after the flare. That flare occurred more than 30 hours ago. Look at the activity from the sunspot group. This guy's not done. Also, look how it's connecting to these other sunspot groups. It's a whole connection here. So that last explosion was really insane in many ways. I think I have it right here. Yeah, watch this. Here's the explosion from that. Massive, massive boom, boom, boom. That is crazy. So huge shockwave, long duration event. That's what you get. This type of solar storm that you get from an explosion like that, right? We see those connections there as well. Well, we saw how wide of an event that was across this entire part of the solar disk. We're seeing similar dynamics again play out right now with the sun. So it's really active and electrical at this moment in time. I wouldn't be surprised within 48 hours we get another big solar storm to launch. Like right after we get through this geostorm, the sun's like, hey, can you take another? So we'll see, but I'm not going to be surprised at all by that. And if it hits X class levels, that wouldn't surprise me. It could be a long duration M class flare. Maybe it's a long duration X flare. Maybe it's bigger. Could be bigger. Maybe what we just saw here was an appetizer for something bigger. This sunspot group really isn't that big, but there is another one close by, and they're starting to kind of work together. So we can check out our sunspot activity quickly before we look at this aftershock sequence or this swarm sequence in SoCal, California. I have to reload this. This is earthevolution.com. This is my website. We have an energy analytics portal here, so you can see a variety of data feeds on the Earth, the Sun, and more. Our Schumann resonances have finally, the anomalous signal has ended now for about 12 plus hours. Almost a 3 hour long or 3 day long anomalous signal Schumann resonance. We don't know what that means long term, but it could be a historic pre-earthquake signal. It's hard to say. So we can look here at our sunspots, and here's our latest one right here. So, it's not like that crazy of a sunspot group, but there is just in general distributed activity over a wider zone. And you see the other sunspots that are connecting into it, though quite a ways away, but we saw it, give us one of the strongest solar storm impacts in decades. So size is not the only thing that matters. It's important. It's not the only thing that matters. It's also the activity level. Just these planetary alignments have a tremendous impact on the sun. And we can say that based off of observational data. It's not me just wanting that to be the case, for example, or whatever. It's observationally, we see that. We don't necessarily know how it's working, right? It's an open question as to how. But just because we don't know the how, because we're clueless, right, and we're ignorant, doesn't mean there's not an actual mechanism at play or mechanisms. So that's the thing. We kind of sometimes, just because we don't know something doesn't mean it doesn't exist. We're not the center of the universe. So let's look at these earthquakes again. California, let's see what's happening. Switch this back here to all magnitudes. Okay, a lot of magnitude, and we'll switch this here. Yeah, a whole burst occurring right now. Here's our magnitude 4.6, 3.3, 2.4, 2.1. Yeah, I mean, this isn't like crazy as compared to like Japan or something, but it's right next to San Andreas. Like, it's right there, folks. So that is one of the biggest earthquakes actually on the San Andreas in quite some time. San Andreas, often, if you watch it, you track it closely, it'll stay quiet until all of a sudden it goes. It doesn't have... It's not like a lot of faults where they're kind of like constantly rumbling with activity. It's often very quiet until it happens. So this could all be foreshock activity. there's about a 5% chance. I'd maybe say 10% chance here. Well, I'd probably actually a little bit more than that right now, considering all the factors, the solar storm, the geometry, all this stuff, right? But this could be a foreshock sequence. Now it's 4.9. Like, what is it, guys? Is it 5.1, 4.9, 4.6, right? Their depth is only 3 kilometers. This is super shallow. That is wild. 3 kilometers. That's just a little bit more than a mile down. 1.6 kilometers, about 2 miles down. A little bit less than that. And we can get big earthquakes here. Big magnitude 7 earthquakes are possible. Magnitude 8 earthquakes are possible. Historically in SoCal, we've seen a lot of magnitude 7.5 earthquakes. Around that range right there. 7.4 to 7.8. It's not every single year, of course, but the year 1800, San Diego had a big high magnitude 7 earthquake. 1812, we saw a double sequence strike the basin. There was one roughly in this zone here, and then it went off, and there was another one about 2 weeks later. Okay, I'm back. I froze. I'm sorry, guys. You know, my computer's pushing a lot right now. We have a G4 storm right now. I'm doing the best I can. I think it looks like I'm back, though. So I'll just rewind a little bit. I don't know how long I was frozen for. But yeah, these earthquakes continue to pop off near this location. 4.9, depth 3 kilometers. That's a little bit less than 2 miles down. Super shallow. And this location in Southern California can get big earthquakes. In 1800, there was a high magnitude 7 that struck near San Diego. In 1812, there was a magnitude, roughly like a magnitude 7.5 that struck, and then three weeks later, approximately like 2-3 weeks later, it struck off the Santa Barbara Islands. Double sequence, I was right, just less than a year after the new Madrid earthquakes. My dad was also telling me recently that 1812 also saw big earthquakes in Venezuela. Let's check it out. A lot of parallels between kind of now and 1812, to be honest. So let's check out the year 1812. And actually, it's going to be 1811 to 1813. Because we'll give ourselves some room on each side. And I don't know why I put 13 there. There's no, well, there should be 13 months. If we were smart, we would use a lunar calendar system and not this 12-month nonsense. I like the number 12, but the lunar cycle is a much better system. You know, they control us through our calendar and our understanding of time. Shout out to David and Bella with QPW. They talk about that all the time. They are well aware of the manipulation of our minds via the calendar system and time. So here we see 7.1 Santa Barbara. Let's go. Yeah, that's fine. This is newest first. That was the last earthquake that occurred. And then 7.5 here near San Bernardino. So that's a double sequence I was talking about. Look at the dates. This is the 8th of December. That was the 21st of December. So 2 weeks later, boom, boom. Now, about a year earlier, we had all these earthquakes in New Madrid. And they don't exactly know the magnitudes on these. So what we see here is not exactly maybe what occurred. Some people estimate that these are stronger. But 7.5, 7.3. Let's actually switch it to oldest first, okay? 1811, this is December 16th, 7.5, 6.3 aftershock, 7.0, 6.3, 6.1, 7.3. Now we're in January, okay? 7.5 in February here. Wow. So there seems to be a connection between these locations, in time at least, with the last big sequence. And let me type in big Venezuela earthquake 1812. See if that is something that 1812 Caracas earthquake. Okay, let's check it out. Took place in Venezuela, March 26, 7.7 on the Richter scale. It caused extensive damage. Here's the location of it right there. I guess the USGS database does not have it in there for some reason. You know, they're slacking. So we can add that into our map here, okay? Let's just kind of add it in mentally. March 26th of 1812. Well, check it out. Here we are. Now, this is all the earthquakes globally, though, as we just saw, it's probably not global because they missed the 1812 Caracas earthquake, okay? But according to their database, but again, all right. Regardless, New Madrid goes crazy here, December 1811 through February of 1812, because we have this set for oldest, right? Right here, Western Tennessee, February 1812. Caracas, March 1812. And then next winter, December, boom, boom, double earthquake in California, right? Don't tell me they're not connected. You got to be crazy at that point to not think that. Same time, similar magnitudes, all in that 7 range for the high end, right? And also following this clear sequence here, here, and there. Clearly, there was some larger plate tectonic dynamic that was unfolding that affected this entire part of the North American and Caribbean plate. And so that's pretty significant. I'm not saying it's about to occur or anything, but I'm just giving you an example of the sort of seismic dynamics that can exist across time. And it can be crazy. It can be really wild. 1906 was a big year for seismic activity. We've seen that before. Let's go back here. See what this earthquake swarm is doing. I bet there's more now. Yeah, there's already a few more now. 3.3. Oh no, we want to set this here. 3.4 being our highest aftershock, though it may not actually be an aftershock. 3.3 as well. 4.9 being the biggest. Again, depth 3 kilometers. So let's look at real-time solar wind, see what's been happening there, see if it's still super, super elevated. And then I want to talk about northward field configurations because that is what we have right now. It's just flipped. And that has interesting dynamics as it relates to the Earth. It looks like it is starting to decrease. Yes. So here, again, our solar wind, real time. And if you're just jumping into this, you're like, who the heck is this guy? I'm your host, Stefan Burns, geologist, geophysicist, space weather guy, your cosmic bro, helping you understand what's happening here on the Earth, providing educational information, edutainment, I guess you could call it. But more so than just watching this and being like, oh yeah, this is cool, is I would like you ideally to, after watching enough of my videos, to be able to go to these different web portals and data feeds and look at things and be able to intelligently understand what's happening yourself. That would be great. That would be great. So, and that is the case. I mean, I've seen across time now how a lot of regular viewers, they're now pinging me, like on X, for example. My handle's at Stefan Burns Geo, saying, hey, check this out, check that out. And they're like, you know, doing really great stuff. It's awesome. So, we're seeing now our solar wind go down 50 nanotesla for the top field strength 25, whereas just back here it was at 6159. So if this suddenly flips to the south, then we got a big storm. Our solar wind's gone down a little bit. It's 950 kilometers per second now approximately, but it's still extremely, extremely fast. And often the structure of this, if you're watching, it's not linear. It's usually kind of like this, and then it'll quickly drop off. Sometimes it'll bounce and go back to northward. There's a whole bunch of different ways the field can be configured. But usually once it starts to slip, it actually kind of drops pretty quickly. So I wouldn't be surprised if within 2 hours we got a southern field and the aurora just sparks up overhead like crazy. So while we're talking about that, let's look at our aurora forecast, okay? Maybe they've updated it even beyond what they had when I made this video this morning. I gave you guys the download this morning. You have to go to our, and they also have a real-time aurora forecast. We'll see if that's worth anything. But here we have the aurora view line for tonight, according to NOAA. Forecasted KP7. I don't know. It was showing 8 earlier. I don't know why they changed it. But regardless, maybe this is actually for like tomorrow night. I'm not. They use universal time, so I'm not exactly sure. But regardless, big aurora viewing event tonight. If that field goes south, and even then, people up in Alaska and Canada are probably starting to see things. Maybe not Alaska yet, but definitely Canada. If you're high enough up, I think you're probably seeing some aurora. We have some webcams that we can look at too, so we'll do that. But before we do that, let's look at our 30-minute aurora forecast, see what it's showing. And it's not just Northern Hemisphere, Southern Hemisphere too, though Northern Hemisphere in general gets better viewing. So it's important to keep in mind. Here we have our aurora model. Okay, I froze again. See, we're cooking, baby. The solar stuff, I'm telling you, affects things. It's not just an abstract thing. It affects us. Maybe not in the most obvious way, but it affects us, right? There are real world implications for this. Crazy stuff. So here is our aurora forecast. We see it right now starting to blossom up. And this goes back, I think, about 24 hours. This may be a 24-hour forecast. So we'll see this surge that that Europe gets from the shock impact. That's going to be pretty cool. Let's give this a watch. It should happen right about here. There it is. And then we see that we sort of have that northward field configuration. And now it's starting to blossom up again for North America. So the next few hours are really going to be key as it relates to seeing the aurora. Let's see what the Southern Hemisphere did. Down under, they're doing the best they can, working with what they got. They're shaking it, they're shimmying, they're grooving, they're doing all the things. Here we see the aurora, the auroral curl, as they call it. We'll see it expand there shortly, but not in a way that's going to hit Africa, Australia, New Zealand, or South America. So maybe some fishermen saw some good aurora. The people on the bases there, but in general, that's why we don't talk about it much. Often you don't see the aurora australis. Sometimes you will, and if we get, again, a big enhancement, we could. But it's more, look at the landmass cluster in Northern Hemisphere versus Southern Hemisphere. That's really important as it relates to geology and geophysics, actually. Few people talk about the landmass distribution. I don't know why, but it's pretty important. And just wanted to highlight a few more super thanks here. Jen Williams, thank you so much for your super thanks. Was the sun's activity normal before 3i Atlas came to the party? Do you think there was a link? Well, all of a sudden, solar activity did start to really ramp up around the perihelion, the closest approach to the sun of 3i Atlas. That was back in October. And we're forecasting that because we've seen with prior interstellar objects like Oumuamua, big activity right as it swung in close. The dynamics are different this time based off of the orbital trajectory and the positioning and everything. But, we started to see a lot of activity, and it basically maintained since then. Then this planetary alignment kicked in and sent everything into overdrive. So, but it has been solar maximum now for 3 years, 23, 24, 25, and now we're at the beginning of the descending phase. And we'll continue to see strong solar activity through the descending phase, so it's going to become more and more infrequent until we're at solar minimum and we can finally breathe a sigh of relief. And then we'll probably ramp back up to a new solar cycle, a new solar maximum, though there's always a chance with the conclusion of every solar cycle that we enter into a grand minimum. They're pretty rare, but they do occur. Okay. Hello from San Diego. Yaman, thank you for the super thanks. Can you go over the theory of planetary alignments, conjunctions, influence solar activity? I see the results, but I want to know why it's so. Well, in general, the idea is that the gravitational influence from the planets is significant at certain layers of the sun. So the the tracheocline, I think it's called. There's this inner layer of the sun. Most of this is hypothesized, but it appears that you don't need much to disturb the solar dynamo. And you also have to consider the fact that, yeah, the gravitational field of the sun is the biggest of all the planets and everything, right? It's like the main factor. But just because something is big and static doesn't mean it can't be disrupted by a small force. If there's variations in that force, and that just is the system in general, then it stands to reason that when there are significant variations in that force, even though in comparison, relative, it's smaller than the sun's gravitational, it is still significant. So that appears to be the case, that when you have these gravitational vectors align with the planets, it does significantly increase. And by significantly, I mean for that system, again, right? In terms of absolute measurements, it may not be, in our minds, that big of a deal. But in terms of that system, it may be significant. Seems to be able to significantly affect these systems such that it can generate flux within the sun that pushes out, creates sunspots, and boom, instabilities. There you go. And it's going to cause disturbances during a solar maximum much more than a solar minimum. So that 2006 sequence that I showed you was at the very end of the descending phase of solar cycle 23. And we still got some big X flares and those two big solar storms to launch towards Earth. Right now, we're much closer to solar maximum because we're at the very end of it, at the beginning of the descending phase. So where you are in the solar cycle matters as well. But we don't exactly know. We don't have a comprehensive slam dunk theory on this stuff. But it seems gravity seems to be an important thing. I think electromagnetics is also important too. But yeah, Diana, thank you for the super sticker, and Celestia, thank you as well. How far south will the northern lights be visible tonight? New Mexico, you have a good chance, honestly. If it goes southward, like I would have your camera ready, batteries prepped, cold jacket, hot cocoa, like all the things. I would definitely be ready. But if it doesn't happen because the field stays northward, like don't be super disappointed. That is a possibility, and it's not an insignificant possibility. It's definitely a possibility. Thank you, Nancy and Josh. Jane, thank you for the super thanks. We are living in interesting times. Jennifer, Jen, thank you for the super thanks so much. Very generous of you. One Earth, one planet, one humanity. We need to act like that. I don't know why we fight each other when we're literally one species and we're driving ourselves extinct in some ways. Tony, thank you for the super thanks. Appreciate the kind words. We're boldly going where no one has gone before. I can't say that. Standing on the shoulders of giants. There's a lot of excellent researchers who've been working on a lot of this stuff for many years now, dead and alive, that I have read into and incorporated into just my overall knowledge base that has allowed me to make these forecasts much more accurate than otherwise. So as it relates to the planetary stuff, J.H. Nelson is key. His book, Cosmic Patterns, is really fast read, but really good stuff. And if you learn more about space weather with the modern info we have, there's a lot of things he didn't know. You add that into it, and it really fleshes out the whole idea. There's other people, too. So, yeah. And Daily Grind, thank you so much. And that's it for the super thanks for right now. So, beautiful auroras in Brittany, France. Let's check out some of our live camps. Let's see what we got. We have some live. I have a website here for live cams, weather cams, and someone told me that we could potentially see aurora on these weather cams. So let's see what we got. And I don't know which ones are good. We're just going to have to zoom around a bit here, okay? And of course, we're going to be wanting to look north. In general, unless the aurora curls actually even further south, and it shouldn't be at this moment in time. As you can see, there's a lot of weather cams, but okay. That looks like something right here. We got a little bit of green on the horizon up in Canada. This is for like aviation and stuff. That's why they have them. This is pretty cool that we have this. But not really seeing much. but it's also dependent on the camera and more. So let's maybe go back over here. What's this one say? No data. Kind of punch through these. Turn Brittany off. And this does not extend to Europe. If you're wondering, hey, go over to Europe, well, it's just FAA. So we don't have any for there. But it is nighttime now for the United States. So at least it is on the East Coast and has been. Yeah, it should be nighttime now for everywhere except Alaska and maybe the Yukon. Should be sunset for them right now. Maybe let's go maybe a little further south, see what we got. Though in general, we're just not getting that much aurora right now because of the northward field. I think in a few hours that's going to change. But right now, we're not seeing it. I do have another website. When I checked it earlier, it was very cloudy and foggy. But we have our Lights Over Lapland aurora cam. So let's see what they got. But as we can see, yeah, foggy, cloudy. Looks like we do have some lights, but it's also like out of resolution right now. It's like out of focus. So yeah, this may turn out to not be that big of an aurora viewing event, but that does not mean it's not affecting the Earth geophysically. We've had a northward field here. So let's talk a little bit about the northward field dynamic when it's in the interplanetary field, because it really changes the magnetic field significantly. And it has unique implications for the geophysics of the planet. So here's a southward interplanetary field. We see that we have these magnetic field connections at different points. We have some that occur right at the magnetopause, and then we also have some that occur in the magnetotail. We have a northward field. Earth's magnetic field stays a bit less compressed. It stays a bit more protected, you could say. But in general, that's the thing. With this having pushed into even closer than 5.6 Earth radii in geosynchronous orbit, that tells you just how strong this is with that northward field. Though that initial shock was southward. So keep that in mind too. It's probably pushed out now because it is northward. But we maintain a bit more magnetic field integrity, you could say, during northward field. But we have these connections here. This is the Earth. We have these connections here near the back of the magnetotail. So not exactly in the center of the magnetotail where there's a lot of plasma, but more like on the edge of the magnetotail. And then we have these injections of energy. It creates really strong Birkeland currents. These are these currents that flow in at the poles. And so the southward field configuration is quite unique. And it charges the Earth in ways that we don't see with the southward component. It creates really strong telluric currents because when you have these strong Birkeland currents that come in like this, they connect at the ionosphere, go back out. They are generating these electric currents in the subsurface very strongly as well. Now you get that also with a southward field. Any aurora you see overhead is creating Birkeland telluric currents below, but it'll probably induce deeper telluric currents with the northward field. I can't say that definitively, but based off of the physics I know, they're probably deeper and stronger. So it's less shallow and like in deeper geologic layers. That could have important implications as it relates to earthquake and volcanic activity. There hasn't been much research done on this, especially that sort of connection. You know, the difference between a sustained northward field, sustained southward field of this strength. You know, our sample size for this is almost nothing, right? How many of these massive solar, near-Carrington level solar storms have we had where then we can track this across time? If we had 10,000 years of data, that would be great. We don't. So we're in this northward field. So just because we're not seeing aurora like crazy doesn't mean it's not affecting us. We see our DST index here. It has been dropping. Let us refresh this, make sure this is the absolute latest here. But it's not that crazy. Back in 2024, the Mother's Day storms or the Gannon storms, this May 10th to the 12th, the DST index, another measure of geomagnetic activity like the KP index, measures the ring current rather than surface-based magnetometer values. It dropped down to negative 406. This one here is about negative 140 maybe. So it hasn't dropped that much, but it is dropping now as this storm continues. And again, as it goes more and more southerly, that magnetic field, it's going to drop more. So we could get this going down to 300. We'll see. It depends on the magnetic field at this point. It's not all about the solar flare. A lot of people talk about the sun and solar storms and everything. Just like it's only the strength of a solar flare that matters. That's not the case. It's the duration of the solar flare. It's how direct was it to Earth? How fast is it? How dense is it? The solar storm, right? The magnetic field configuration of that solar storm. All these matter. So it's not just the peak X-ray flux, which is how you characterize a solar flare, that matters. The Carrington event was estimated, we don't know, is estimated to be a 45X flare. But we don't know. But it's not just about that. It's about all these other factors. Now, the Carrington event also had all those other factors. It was fast, good connection, all the things. But just because this is an X 1.9 flare doesn't mean that it can't be near Carrington level, because it's very, very fast and has some of these other factors. Long duration event, really nice to Earth direct for the most part. So pretty wild stuff. Just looking through here, I want to see what's happening. And here is our X-ray flux over the past 7 days. So you can see how this has been increasing. There is that 1.9 X-class flare. You can see that we continue to go up. Here's a key thing to notice. Often when you get a big solar flare, if it goes just down like this and then kind of goes back to baseline, that's showing that the system is depleted. It was like a one-time deal. But when you get these jumps up afterwards, that's showing that this was not just a one-off event, that there's a lot more energy there. Because these solar flares are explosions of energy. And one of the ideas, and there's evidence for this, one of the ideas of how these explosions occur is that you have particle flux going down towards the sunspot. They hit these double layers. I talked about these electrostatic double layers, right? These voltage gradients that are very steep. They hit that. The particle flux accelerates, slams into the sunspot, causing it to destabilize like a trigger mechanism and then explode. So these little flares are indications of that dynamic where you're having this particle flux bombard down, causing this overall level instability, right? Even though we had a huge explosion like this, in the grand scheme, that amount of energy released from the sun is nothing compared to its overall amount of energy. So it doesn't mean we can't have another. If the sunspot's still there and it hasn't totally lost its structure and we're still seeing activity, that shows that we could still have another big solar flare. And as you see here, we had these M-class flares and then a C-class flare, but we were at the low C-class zone before we popped off. Right now, recently, we've been at a higher level. So the overall trend has been going up. This could be an appetizer for something bigger. It's certainly possible. So I will keep you up to date on all that and much more on the channel. If you subscribe, I release videos almost daily. Today's been 2 videos, one in the morning to give you the heads up that something was coming, right? A comprehensive update. And then, the live stream right now as it's coming in. I'm sure that I'll have more to talk about tomorrow as this storm progresses. In about 12 hours, we're going to have a lot more data, good photos of aurora and such. We'll sign off by going to spaceweather.com, see what they say. They may have some pictures of aurora. Here's a good graphic. Let's check this out. This is good context right here. Since the launch, and I haven't gone to the website yet, so I don't really know what they've been talking about, but you can get some good mainstream info and data from spaceweather.com. As it relates to the planetary alignments and everything, they're starting to talk about a little bit more, but they're not really on top of it, I would say. And that's fine. Not everyone needs to be. There's something to be said about just doing good, simple reporting. Regardless, today's CME, while extremely fast, is only half as fast as a true monster coronal mass ejection. Nevertheless, it is capable of producing severe to extreme geomagnetic storms with aurora in the USA as far south as Arizona, Texas, and Southern California. So here we see the distribution of velocity for coronal mass ejections going from 1998 to 2001. 4,315 coronal mass ejections. Here's today's. Very, very fast. Definitely well outside the bell curve as an outlier, but not Carrington level. Near Carrington level, but not Carrington level. Carrington level would have reached Earth in less than 20 hours. This one took about 30 hours. So the fastest observed coronal mass ejection was on July 23rd, 2012, clocked in at 2,900 to 3,500 kilometers per second. So that's pretty insane. The vast majority of coronal mass ejections are slower than 1,000 kilometers per second. So our bulk velocity, and that's usually like the shock wave. The bulk velocity for the storm came in at like 1,100 kilometers per second. So wild stuff. We're going to finish actually by looking at the USGS, and let's see what's happened with this earthquake sequence here near Indio and SoCal. Wow, it's really popping off. All right. Still 4.9 as the strongest earthquake in this sequence, but now we have 31 events that have occurred. And we had this happen live on the live stream just about 50 minutes ago. 37 minutes ago, I think it is. No, 47 minutes ago. So this is a breaking development. Also now it looks like it's spread out a little bit. Check out these two quakes too. They're red because they're recent. That's small though, 0.9, 1.3. They're not big, but they did pop off. Of course, you see the distributed activity across Southern California, these low magnitude ones or whatever. We can switch this to be 2.5 or greater. It's a little bit more of a refined look. If we look at that, we only have the 2.9, 3.0, 3.3, 3.4, 4.9. Now, it is important, if we reference this, to talk about San Ramon, because we've been having a lot of earthquake activity in San Ramon. It's been magnitude 1s and 2s and some 3s, 3.8, 3.8, 3.9, 4. I think we've had up to a 4.2 or 4.1, somewhere right in that zone. A 4.9 is going to be stronger than all the earthquakes released in San Ramon over the past few months. Hundreds of earthquakes because of how it scales. Magnitude 4 is going to be quite a bit less than magnitude 5. Magnitude 5 will be 32 times more energy. So we're not seeing any of these earthquakes now in the past day for San Ramon. It's been really active in November and December. It has cooled off a little bit since then. It's now January. But if we're talking about overall earthquake dynamics, let's go back to for California, let's go back to our 30-day and switch it to significant worldwide, but we're really only looking at California here. We see the Susanville quakes, okay, 4.9, and then also that 4.7. We see here 6.0, Oregon, 4.9, Indio. And if we add in, this isn't just for the past month, but if we add in San Ramon, cumulative about 4.4 or so, probably about 4.3, 4.4, somewhere in that zone, right? Then this is the activity. Here, 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 there. So it has been building up in California. Now the main area that I'm looking at for a big high magnitude earthquake, if we are to have one, is going to be in Central Asia. Because we can look here. And actually, let's set it to 30 days, 4.5 plus. This may be better right there. This is the past 30 days of activity. And you'll see that today we had a magnitude 5.6 in Pakistan. So we've had a lot of magnitude 5s in the stands, right at the northwestern edge of the Himalayas. See this? 5.6, 5.3, 5.3, 5.2, 5.0. So that one is right there up near the Gobi Desert. I believe that's the Gobi Desert. But regardless, there's been a lot of distributed magnitude 5 and 4 earthquake activity in this location. That 3-day long anomalous Schumann signal that we saw is observed in Tomsk is just nearby, and we observe this sort of signals much more often from land-based earthquakes, not ocean-based ones. So that is the primary location I'm looking at for a high magnitude earthquake if one is to occur. But there is a long history of California producing weird electromagnetic signals before high magnitude earthquakes. We have that data from December 2024 showing that, where Tomsk picked up electromagnetic signals just less than a week before the magnitude 7 that struck off the coast of California. And that was an ocean-based earthquake off the coast. So that's odd. But that was the strongest earthquake occur right around that time frame. So Central Asia, California, looking like the biggest hot spots. We have had a little seismic burst that just hit the Philippines right here, as you can see, 5.3, 4.9, 4.7, but it hasn't continued. So it's just those three. Philippines have been very active, though. Japan is still high risk because of all the activity over the past few months. So that's your update, and maybe South America sees something. The biggest ever recorded down here in South America, so we can't discount that. So that is your update for today. For now, I think I'm going to call it at this point. It's been fun, everybody, but I think it's time for me to go. And just want to, super sticker, thank you so much for that. The field is headed further south as you speak. Yeah, that's what it seems. Thank you for the super thanks. Thank you for the super thanks. And thank you so much. Should the Pacific Northwest be worried about the big one? It can happen anytime. Just be prepared, but you don't want to be going to sleep every night freaked out, afraid that's going to happen or something like that. That's just going to take years off your life. That's how that works. You got to live fearlessly as best you can. One step at a time. Take it forward. The significance of a shallow earthquake is the fact that it's going to rumble more. More energy is going to reach the surface. It's going to be more destructive, right? You're going to feel it easier. So yeah, shallow earthquakes they're the most destructive earthquakes. The shallower they are, the worse they are. Sometimes there'll be a big magnitude 7. Like a good example is I think Seattle. I don't remember the year, but there was a big earthquake that occurred in and around Seattle area, but it was deep. Maybe it was Vancouver, that zone, but it was deep. So the amount of energy that actually reached the surface was not that much, thankfully. If it had been shallow, it would have been way worse. So yeah, shallow earthquakes are not good. Celestial Gatekeeper, thank you for the very generous super thanks. That's very appreciative and appreciated. So thank you so much. And Daniel Nelson, thank you for the super thanks as well. So we're going to continue watching this. I'm hoping to see some aurora tonight, but I'll be signed off for the rest of the night. I won't see you all until tomorrow. I will probably be posting updates in between, that time period tonight on my X account. That's at Stefan Burns Geo. So if you want to go there, follow me or not, whatever. You can do whatever you want. You're a free person, hopefully. But you will see latest updates from me and also from some different perspectives as well. So thank you all so much for tuning into the live stream. Really wishing each and every single one of you the best. This has been a big storm. I know a lot of people are feeling it very strongly. So I recommend you do what you need to settle down, calm down, ground, whatever. And that would be a good thing to do. Meditating, breath work, even just some simple stretches, anything like that is super, super useful at this moment in time. Just water, maybe even start fasting a little bit, reduce the food. Or if you are eating food, I recommend you eat more plant-based, especially during these storms. That's just a general smart thing. Like I had Chipotle for dinner tonight. I want to get some food in me before I started, but I got the sofritas and not the beef. So, and actually the sofritas are really good from Chipotle. So, but that's an example of how you can intelligently navigate these energies a little better, right? Instead of just sticking with your programming, oh, I have this breedable every single time. Simple example, but switch it up to something that's going to be a little less stressful for your body, because these storms activate your sympathetic nervous system. They secrete cortisol. The whole stress response gets activated. They can be tough on the heart, especially if you have cardiovascular issues or you're a sensitive population. That could be heart disease, if you're elderly, all these factors. So yeah, wishing you all the best. I'll be back tomorrow. I hope we all get to see some amazing aurora. I hope you get to see them as well. Sending you lots of love and light, and I'll see you all very, very soon. Thanks so much.